Welcome back. 6th of November today. Hope you had a wonderful day yesterday, learned new things, met new people, and perhaps even thought some new... You have maybe had some new ideas even. I hope so. Because we are dealing with important things here. We're waiting for some more people entering the room. Today's program, we will start off here with a plenary session. We will focus on industry and end use. I think it's very important, this session, because you, the speakers here, represent the market, the ones that will make things happen, really. So you rely perhaps on policy and you rely on technology, but you are the ones that ask for the fuel, so you are very important. Then we will have a coffee break, and we will continue with 2 parallel sessions. After that, there will be a lunch break, and also after the lunch, there will be an additional workshop. After the 2 parallel sessions, we will have a half an hour closing remark session here in this hall, in this room. So I kindly ask you, the ones who are in that room, to move to this room, because there is no break in between. Did you understand what I say? Yeah. So it's my pleasure to invite the first speaker when it comes to end use and industry. Please welcome Anna Soltorp. You are Sustainability and Political Affairs responsible person at Flyg. You will discuss with us fossil-free domestic aviation in Sweden.
Thank you.
It will be so interesting to hear what you have to say.
Yeah, thank you. It's really nice to be here today and talk to you about how we want to create fossil-free domestic aviation in Sweden by the year 2030, and also about a very interesting research project that we are involved in. For me, it's also a privilege to work in the aviation industry at this time when society is changing rapidly, and we have strong incentive to transform our business models so that aviation can be a part of a sustainable future. Fossil-free domestic aviation in Sweden by the year 2030 is a goal shared by the industry. The roadmap exists, and there is a lot of hard work going on out there to make this happen. It's a bumpy road sometimes, but I'm quite convenient that if we work together, we can get there. BRA, that stands for Broughton's Regional Airlines, and I forgot that I need this one, so I just tried to do something about it first. No? Yes. Oh, okay. I use this one, so it works. It stands for Broughton's Regional Airlines. It's a rather new brand in Sweden, but the company has its roots going back to the end of World War II, when the Broughton's family, a Norwegian family, made their first steps in the aviation industry. And we still have a committed owner in Mr. Broughton. We fly domestic in Sweden with the Bromma, the Stockholm city center airport, as our hub. We represent 1/3 of the domestic market, fly to 14 destinations in Sweden. And today we face a tough crowd of stakeholders out there. People demand us to produce fossil-free, sustainable aviation in a context where the domestic market is losing about 10% due to new aviation tax in Sweden, travel policies that might choose the easy way by prohibiting flying instead of encouraging responsible and sustainable flying. And as you know, there is also the, what we say, Greta effect, or the flight shame, which is after the smorgasbord and the ombudsman. We have the Flygskam as the Swedish third contribution to the global vocabulary. But even before Broughton's Regional Airlines was created through a merge of different regional airlines, we understood that working on minimizing our climate impact was crucial to our future success. And I'm proud to say this, but as far as I know, we were the first airline in the world to take some really important steps. Already in 2009, we ESO certified our environmental work. And in 2017, we started offering biofuel to our corporate customers and also allowed our loyalty customers to swap points against biofuel. Last year, we started to propose biofuel as an add-on when you buy an airline ticket on our web. And this year, we have started to compensate for all our emissions of greenhouse gases plus 10% through investments in renewable energy. And we have also launched a new ticket class. We call it Environment Class, and we did this to nudge our customers to make a more sustainable choice when flying. So when you fly Environment Class, you contribute to adding biofuel to the Swedish domestic market or Swedish domestic aviation, about the equivalent of your share of the fuel consumption, and of course the emissions are being compensated for. So we have transformed our fleet into modern ATR 72-600 turboprop aircrafts, the most climate efficient aircrafts for shorter distances. We continue this transformation, and we will fly with almost only turboprops and only a few jet aircrafts for the longer distances that we fly. So this will have a considerable, and it already has a considerable impact on our environmental footprint, as turboprop aircrafts not only are more fuel efficient than jet aircrafts, but they also fly lower, and therefore the climate effects are less. No high altitude effects. So we think that for the moment we do everything we can to reduce climate impact. We eco-drive our fuel-efficient aircrafts. We stimulate the market to get as much biofuel as we can, and we climate compensate for what we cannot get rid of. So what is the missing piece to get sustainable aviation in Sweden? Of course, we need access to sustainable biofuel in sufficient quantities to a reasonable price. We stimulate the market, but it's also important for us to promote research and technical progress. And that's why we are also involved in a very interesting project on biofuel production from residues from the forest industry. As many of you know, Sweden has a history of technical innovation, and we think that we can change things around better by leading the development rather than by shaming ourselves. So Sweden is covered by more than 50% forest. And we think that Sweden has a unique possibility to develop green technology. Only a few percentage of the unexploited growth of the Swedish forest resource would be enough to make biojet fuel for the need of all domestic flying in Sweden. So we are one of many stakeholders in this interesting project led by Luleå University of Technology, and it is supported by the Swedish Energy Agency as main financer. The goal here is to provide a technical validation and demonstration of the value chain from forest-based feedstock to the actual use of biojet fuel in aviation. And we think the combination of knowledge and technology from the partners in this project will allow us to, first of all, verify the feasibility of a full value chain demonstration with regard to both technology and cost, and then showcase the physical supply chain and commercial use of the product produced biojet fuel in a demonstration project, and develop business cases that prove the commercial viability of the value chain to support the scale-up and commercial potential of the technology. A scenario-driven business case model will be developed, and combined with sustainability analysis and market assessment, this will be a concrete roadmap for commercial exploitation of the technology. And the results aim to lower the investment risk and contribute to create conditions for the first commercial biojet fuel production plant in Sweden. You know that Sweden is a very, very long country. So in Piteå, in the north of Sweden, an existing pilot plant owned by Luleå University of Technology offers the opportunity to demonstrate this proposed concept to produce biojet fuel. And this can be done in a cost-efficient way using an ASTM-certified pathway for pre-commercial full value chain test. So if we add a Fischer-Tropsch unit and an upgrading process to this existing infrastructure, it will make this plant suitable for production of 300 to 600 tons of biofuel per year. The concept that will be tested combines forest residue and renewable electrical power as feedstock. The combination can, in theory, double the quantity of biojet fuel from the same amount of biomass compared to using only biomass as feedstock. And of course, this is an important achievement as the demand for biofuel is increasing. And you know that the resource is limited after all. So the map here shows the existing forest industry in Sweden. Every circle indicates a possible location for biojet production integrated with an existing forest industry. So as you see, there are many possibilities here. And this offers a centralized production possibility that would create a lot of social benefits, like employment, creations of SMEs in the local communities. The climate challenge is global, but we really believe that the solutions have to take local conditions into consideration. So the partners in this project cover the major part of the value chain, and to me this is a good example of cooperation between industry, academia and public authorities, which is a key component to success. And the concept in this project was identified in 2017 as the most promising production pathway in a Swedish context. And we are now in phase 2, gathering data for a full value chain demonstration project and establishing commercial business case scenarios to minimize commercial risk. After this, a large-scale biofuel production chain will be built with the perspective of offering sustainable biojet fuel to the aviation industry. And here you can see the present drivers for sustainable aviation fuel. For instance, the Swedish aviation industry has created a roadmap to become fossil-free by 2030. There is a proposition for a reduction quota to come, according to the government's investigation, and this system is, as you know, already in place for diesel and gasoline. On the European level, then, we have the Renewable Energy Directive that points out a preferential treatment when biomass is used for aviation compared to road transport. And the carbon footprint of the industry is included in the EU ETS emission trading system. And on a global scale, the international CORSIA system will commence its first phase in 2020. And CORSIA is based on offsetting and includes all international flights. And the first goal of CORSIA is to stabilize the level of emission on 2020 year level. So there are things going on, and we need political acknowledgement for the need of domestic aviation in Sweden. I think this is really important for the economic and social development of our regions and of our country. And we need long-term political incentives to make it interesting for investors to invest in production plants, because this is step one. It must be realistic for producers to produce an affordable and accessible biofuel in sufficient quantities. And if this happens, it will lead to long-term agreements between suppliers of biomass, producers, and off-takers. It will also lead to a sound market for biofuels for aviation and conditions for the development of sustainable aviation in Sweden. So for us as an airline, developing new technologies and smart solutions beats flight shame every day of the week. We believe in moving forward together with other stakeholders to create and invent so that we can fly responsible, sustainable, and fossil-free in the future. Thank you.
Thank you so much. Please think of questions to Anna. I have some questions for you. When you see the development in, let's say, 10 years, what are the most important things needed to happen? What are the bottlenecks?
We need to start producing biofuels. We have to stop talking about whether or not the resource is sufficient for all our needs on Earth. We have to start where we stand and get things done, because biofuel is what is missing to us. So, and then we have the electrification, but it's much further away, even if we now have fantastic Swedish initiatives with like 19-seater small aircrafts. It will take time, and it will be only for like smaller and shorter routes. So I really think that we have to get the things in the ground and start producing biofuel.
And that is getting too slow. It is too slow tempo today.
Yeah, I think so. Because this is that's the only thing that we can't get today.
I wonder, when you meet other aviation companies, let's say if there are CEOs they are meeting, how high up on the agenda is this issue?
Well, I was in Köln to meet European Union Aviation Safety Agency just a couple of weeks ago, because there is an initiative working on eco-labeling aircrafts. So EASA is holding this. And I think that something has happened, and I wonder if our Greta is not part of this, because there was much bigger interest in what I said now, and I really understood that people started thinking about that, what we live in Sweden now, with changed possibilities to develop our business, with like threats or opportunities, depending how you see it, will also come to the rest of Europe and the rest of the world, but it takes some time. So I think it's moving upwards.
Yeah, and you also touched upon different kind of policies. And you say, okay, we need to fly. It's important that we do that we can commute. And but you were also kind of critic to some of the policies implemented today. What kind of policy would you like to see to make things happen?
I'm generally very afraid of this black and white or yes and no context that we live in together today, when it's hard to have a nuanced debate on things. Either you are against or you are for. And I would like to say you have to think holistic, you have to look at different aspects, and you have to make a wise choice every time. And being categoric, saying that you're not allowed to fly, is probably not at all the best environmental choice you can make. So but it takes more work, and it's harder to develop in that kind of context when you can't lean against that tick in the box that you said, we're not flying in this company. But then you have to think a little bit more. So more flexibility, more shades of gray in this black and white debate that we have today.
Interesting. All right, I open up the floor for questions. Are there any questions to Anna about aviation in Sweden and the possibilities for the future when it comes to biofuels? One there and one there.
I was almost afraid there would be no questions. I would have been sad to go away from here with no questions at all.
So you also like to be on stage?
I like questions because maybe I learned something.
Okay. What are you planning to do with the problems with parts of EU that they say that it is a kind of environmental crime to use biomass and produce biofuels?
I'm going to Brussels next week to meet a great number of European you see what I mean, members of parliament. And I'm doing this together with our organization for regional airlines, and we're going to talk about this, for instance, explaining that we have to take local conditions into consideration, and that, because I think this is also part of this black and white way of looking at things. So I'm on my little scale, I'm doing what I can, but this is one thing I'm doing.
Good.
There was another question there, yeah?
Hi, I'm John Wagner from Loughborough University. First of all, thanks for the talk. Very nice that you're working on this. My question is about the fuel standards, because when I worked with Airbus before, that was the main concern with biofuels. Can you comment on that? How do you get it certified?
Yes, no, I can't, or yes, I can. I think that in this context, the certification is not a problem because the pathway is certified up to the extent where we are now and a little bit further. But before commercializing, something has to be done, and that will probably take a couple of years, at least. But I'm not an expert on this fuel certification things and so on. So Fredrik here, if you take his email, you can always write to him and ask him all the questions, because he's really an expert on this.
Okay, thank you.
So I'm sorry I could, but then I said I learn from questions, so I will find this out for the next time.
There is one question over there as well, yeah.
Hi, Patricia Thornley, Aston University. I mentioned yesterday what we had done previously in the UK on this and the perspective of the Committee on Climate Change. And if I try to sort of put it really simply, and I'm not saying for 1 minute that I agree with this, but I'd be interested in your response. The argument runs that turning biomass into something that will be suitable for the specification of an aviation fuel actually takes so much energy that there are better things you can do with the biomass. And it makes more sense, therefore, to continue to fly planes on things that come from fossil, if we accept that there's anything fossil out there, and to use the biomass for much simpler things where they can provide, you know, a bigger impact. Now, I think there's lots of arguments why that's wrong, and there are different perspectives, but I'd be interested in hearing your position on it.
Yeah, it's a complicated question in a way, because it's about the same consideration as when I got the question, why did you take the biofuel from California, ship it here, and fuel it in Sweden instead of just pouring it in somewhere in California? Why did you sacrifice 10% of the LCA benefit for this product? And I had to answer, well, it's because we are human beings, and we act differently if things happen close to us or far away. If we want things to happen, we might have to do things that are less environmental perfect, but that might have bigger effects in the next step. And I'm not at all a technician or an engineer. I have heard this argument also, but I cannot say whether it's correct or not. But I think that that's not the only perspective.
Thank you. I think we thank you for this speech and answer. Thank you so much, Anna.
Thank you.
Now we move from aviation to the maritime sector and shipping. We welcome Anne Sophie Vinther Hansen. You are Senior Innovation Project Manager at AP Møller and Mærsk. And you will discuss with us net zero emissions by 2050, a maritime approach to renewable energy transition.
Yes.
You are from Denmark?
Yes, I am. Hi, and thank you so much for inviting me. And thank you, Anna, for a very interesting presentation. Perfect, thank you. So, I come from Mærsk. Might know the logo. We move boxes around the world. We're an international company, and we're present in 130 countries. The number that I would like you to think about during the presentation is that right now the fleet that we have counts around 700 vessels. And those are the ones that we want to try to make zero carbon. We are a company with quite a long history. We're more than 100 years old. And throughout our company lifetime, we've been involved in lots and lots of different areas. And every once in a while, we try to slim the organization down and focus. And the last time we did this was in 2015, when we decided to get rid of our fossil division, our energy division. So Mærsk Oil was sold off. It now belongs to Total. Mærsk Drilling had an IPO and are now independent and out of our group. Mærsk Tankers that ships petrol products and lots of other stuff around the world was also sold off. And this is what we do now. So we have the shipping, which is the core of what we do. We have our terminals division. We do land freight as well. We also produce our own containers. And then we have our tugboats, the Switzer, and leftover from the energy division, we have Maersk Training, where we train seafarers, and Maersk Supply Service, which is the company that's working with the ocean cleanup now. What we want to do is to connect and simplify global supply chains. We want to make it super easy to move things from A to B. We want to do it efficiently, and we want to make it easy for our customers to get their goods wherever they need to be. Sustainability is, of course, a broad term, and while I, in my department, focus very much on the decarbonisation, we do have quite a broad approach to sustainability, which includes not only environment, but also employee health and community engagement and lots and lots of other things. We've been working with SDGs for a number of years. We're one of the founding partners of the Global Compact Network. And we use this internally for lots and lots of different initiatives. In an organization counting 80,000 people, we have lots and lots of different initiatives, obviously. But the light blue ones are the ones that are most important to us at this time. And you'll notice that this counts to help multiply the benefits of trade, specifically for the developing countries. We also want to lead the change in the ship recycling industry, because we get very, very sad when we see a big ship with a star on it stuck on a beach somewhere in the south of Asia, polluting and being a nuisance for the local population and so on. So we very actively try to engage there to make sure that we don't just sell off an old vessel to a single certified off-taker, which might then resell it and create a problem down the line. Also, we want to contribute to halving food loss. About 1/3 of everything harvested from the field goes bad before it reaches anybody's plate, and that's a lot of food. And since we are transporting 25% of the transported food in the world, we think that we can make an impact here. And then finally, what we're here to talk about today, to help decarbonize logistics. So the shipping sector is responsible for 2 to 3% of the man-made carbon emissions. And we've been working quite actively for a number of years to try to decrease our carbon footprint. It's not just good sense, it's also good for the bottom line, because when you use less fuel, then you can ship stuff cheaper. The IMO has decided that 2008, that's the benchmark year for the shipping sector. And compared to the 2008 numbers, as of last year, we had reduced our CO2 emissions by 41% already. And we've done this in a combination of different ways. So there's aerodynamics, there's smarter hull designs on our vessels. When we make our container vessels larger, we can ship more containers, and that makes it more fuel efficient for us to do so. Slow steaming, when possible, within our operations, changing our operations slightly. Better energy management systems on board of vessels, etc., etc. And we want to continue these efficiency gains. And doing so will get us to 60% reduction by 2030. And that's about as far as we can go with the efficiency gains. Now, the IMO, they've set targets that are somewhat below this number, even for 2050. So we were facing a choice in the end of 2018. Do we just lean back and say, we're the good boy in the class, we don't have to do anything more? Or do we want to do something more ambitious? Do we actually want to try to figure out how to go beyond these 60% and try to make a real impact? And that's what we did. So in December of 2018, our CEO stated that we have begun a journey towards having net zero CO2 emissions from our own operations by 2050. this is an important ambition and one that we can only deliver on in collaboration with many other stakeholders. This is to say that we're not going to hire a bunch of PhDs and stick them in a basement somewhere and then just expect them to make a Mærsk-only solution. That's not how energy transition is going to work for the shipping sector. We want to work broadly. We've started engaging in a number of different kinds of projects and really try to take a step back, not just sit in our offices and try to alter stuff that doesn't exist yet, but actually engage actively. If we do nothing, then our emissions are going to follow the growth in our fleet. Right now, we are actively trying to decouple ourselves from this development. But in order to get to 2050, we need solutions that are not currently in existence. So we want to work very actively with researchers, with small, medium-sized enterprises, OEMs, etc., in order to try to drive the change to actually get here. And this poses something of a challenge for us. When we made this pledge that by 2050 we're going to be, our vessels are going to be zero carbon emission net, a lot of the feedback we got was, oh, come on, 2050, that is such a long time. Why don't you set more ambitious goals? Why don't you try to do something? And I think for the heavy transport sector, the asset lifetime is really, really important. And try to illustrate that here. So in order to have our first carbon neutral vessel by 2030, which is what we want because our asset lifetime is approximately 25 years. So in order to have a net zero emissions fleet in 2050, we need to have our entire fleet shifted out towards carbon neutral vessels, and we need to retrofit the ones that we do have from the old fleet. Otherwise, it's not going to be possible. Now, in order to get this vessel by 2030, we need to order it at least 2028. Usually it takes 2 to 3 years to build a new vessel. In order to do that, you have approximately 4 years' work of design, because these are huge, huge vessels. There's lots and lots of moving bits and pieces, and it's a complicated job. In order to make a finished design by 2027, we need to spend 4 years to get the solution that we're looking into approved. In order to operate a vessel, we have to have class certification, we need a flag state certification, we need all these things to be in order. And it's a very, very lengthy process because it goes towards operational security. Is it hazardous for the people working on the vessel? Is it hazardous for nature? And so on and so forth. So that means that we have to have a decision point by 2023 about which technologies that we're going to be looking into. Otherwise, we're not going to make it. So right now, we're looking broadly. That's what these arrows are meant to signify. And we're in dialogue with lots of different stakeholders. We're involved in many different projects. And for better or worse, a two-stroke engine, which is what we use in our vessels, is vastly different to the gas turbine engines and other things used in aviation. So in a way, we have possibilities that some of the other transport sectors don't have. That's the good news. The bad news is that we need to sort through all these different possibilities and arrive at the most sustainable, the most operationable, the cheapest one, etc., etc. And that's quite a challenge for us. This is not an exhaustive list of the different types of fuels that we've been looking into. This is meant as inspiration. And you'll notice here at the bottom, we have what's called moonshots for standalone deep-sea transport. And that's because when you have near-coastal traffic like ferries or barges or sometimes even cruise liners, then it's possible to run a lot of your operations on batteries or on fuel cells. And that's fantastic. We could do the same in a near-coastal environment, probably, but for deep-sea transport, these solutions do not cut it. There's not enough energy for the operations that we need to do in order to move goods from one continent to another. So, we foresee a future where, much like the other sectors, there's going to be hybrid systems, dual fuel systems and so on, but we're still going to need some kind of internal combustion engine, and we want a clean fuel to go with that combustion engine. And there's two things that we want to do. One is try to figure out what is the best fuel candidate for the future. It needs to be scalable, it needs to be cheap, it needs to be safe, it needs to be sustainable, all these things. And until we get there, until we have all of our vessels shifted towards this new design, how do we decrease the carbon emissions that we currently have with the vessels that we're operating now? And you'll notice here at the top we have bio and e-fuels, drop-in blend-ins, and that requires minimal change, so it's something that we can start doing now and that we are looking into. Then move down, the low flashpoint fuels, these are different types of alcohols, combinations thereof. We need different engines for that, different pumps, inlets, and so on. We also need a different fueling infrastructure on board the vessel. None of our vessels right now are capable of operating with fuels on board with a flashpoint of less than 60 degrees Celsius. Otherwise, it's going to evaporate into the vessel and not make it into the burn chamber, which is not an option for us. So some retrofit will be needed. Or we could build new vessels with alcohol engines and with fueling infrastructure to go with that. Excuse me. Then we have the gases. And when we get to the gases, some of the calculations that we're trying to do is, of course, okay, so in theory this should be cheap. It should be cheaper than just elongating whichever chains that we're producing into a hybrid carbon-like fuel. So that's good. But then the volume is so much bigger for us to get from A to B. We need larger fuel tanks. In order to have larger fuel tanks, we need to figure out how many containers are we going to pluck off the vessel, and how do we make that work in the end. So, all ongoing work. In March of this year, we had the world's largest biofuel pilot for the maritime sector, where we sailed Mærsk, this vessel, from Rotterdam to Shanghai and back again, using 20% FAME from used cooking oil and 80% heavy fuel oil, so that would be bunker oil. We did this with a bunch of great partners from the Dutch Sustainability Coalition, and it went splendidly. So we didn't have any technical issues, and we had quite a lot of interest from our end customers, the people who need their goods moved around the world. And we've now converted this into a commercial offering where companies like HMN and several others then pay a premium to claim the CO2 credits, because that's how we can make this work. If it's certified, if there's credits to go with it through the ETS, through something similar, then our customers become excited because they can claim those credits for their own CO2 accounts, proving that they are actually trying to ship their goods in a more sustainable way. We also had this press release come out recently. So this is a lignin ethanol blend fuel that we are looking into together with Wallenius Wilhelmsen, BMW, H&M, Levi's, Marks & Spencer's. And the idea is to try to raise the calorific value of ethanol fuels to see how that would work in a maritime setting. And we had yet another press release recently. Earlier this year, we did a study together with Lloyd's Register, which is one of the companies that get to certify vessels for us to use out in the real world. And they arrived at biomethane, ammonia, and alcohols as the most promising routes. That's not to say that we're going to start sailing on this tomorrow, but we're going to spend quite a lot of our time looking into this, figuring out if this is really the way to go. And we are, as anybody, cursed by only having the knowledge that we have. And we need to do iterative processes in order to validate whether or not these are the right pathways to do or not. It's not going to be the only fuels that we look into. but it's going to be a major part of the activities that we have moving forward towards this carbon-free vessel of the future. Now, we make the very best assumptions with the knowledge that we have as a company. There's the technology part. It's of course important. Will it work? There's the practical economics. Can we scale it? Will we end up at a price that our customers are willing to pay for? And then there's the sustainability, the entire impact on the environment, all the things that we try to make good judgment upon with the knowledge that we have. But we really, really want you guys to get engaged. When we have press releases stating that alcohol, biomethane and ammonia might be the future pathways, please speak up, because we want to know what you guys think. We can't do this alone, and we're not trying to do it alone. And for me personally, this is this is just me talking. I'm just so fed up with industry reports because you can see from the sender which technology is going to be the best one before you reach the last page, and it's so uninspiring. It's much more interesting to hear independent researchers make broad assessments and try to give their best towards this journey that we're on. We're in a really, really short time frame to make good decisions. We want to make the best possible decisions, and we need your help to do it. So this is me. Feel free to look me up. And any questions?
Thank you so much. I liked your slide where you had call for action for scientists.
Yes.
When I was a PhD student some 20 years ago, I worked with the pulp and paper industry. I would have loved such a slide. They were not that interested at that time.
I'm sorry to hear that.
Things have changed.
Good. We agree on that.
Given that biofuels and biomass is a limited resource, should you have it or should aviation have it?
It's a good question. Most of the biorefineries that are currently producing biojet have significant side streams that could be suited for our engines, could go to road, could go lots and lots of other places. And I don't see this as a competition. I think we as a society and the sectors in between need to figure out how best to utilize the resources that are available, which is exactly what we did 150 years ago when we started this fossil journey to begin with. And whatever the resource, ideally it has to be sustainable, and something that we struggle with a lot when we have both internal discussions and also when we try to engage with other industry partners, with legislators, NGOs and so on, is this struggle to figure out, is it more sustainable to go bio? Do we want to only use e-fuels instead? Because then there's no effect for the food production, there's no effect for all these things. And that's of course true. But CO2 should come from the atmosphere. That's where we should get our carbon from. Whether or not it goes into a plant first and you have a side stream of food production and some residues that you can then utilize, or if it goes into a big chemical plant and comes out on the other end as some type of fuel or product, that shouldn't matter. The route needs to be the most efficient, the most sustainable way to get there.
I'm asking that question because you mentioned that the shift for the maritime sector takes a long time.
Yeah.
And what if others are there before you and asking for the biofuels?
We're showing up late to the game, so definitely other people are there before us. And that's good and bad. Some of the technology that have been disproven for aviation, for road, etc., might be applicable, so that's something we're looking into. And a lot of the work going into those technologies already happened, so that's good. Lots of the legislation, the CO2 credits, ETS scheme, etc., that has been pioneered by other people than us. And our customers, when they reach out and say, we want sustainable shipping, we want to move our goods in a sustainable way, and we say, okay, so we can source some fuel from you from somewhere. What are your requirements? They'll say, well, we want it to be sustainable. No dead orangutans, no shitstorm on Twitter, And also, if it could be RSB certified, ETS, etc., that'd be good. And these things exist. We, of course, have to adapt them to the maritime environment, but we're happy to do that, and also really appreciative of all the work that's gone before us. So standing on the shoulders of giants here.
I was also a bit curious about your long-term goal. You had net zero emissions. What does net mean?
So depending on the specific source, moving the fuel from a production site to a vessel, that's going to take some energy. And we need to look into how to optimize this the best possible way. Getting to zero, that's going to be extremely hard. Some people say, well, you should just do like the Russians and the Chinese, just go nuclear. And of course that is technically a possibility, but I foresee a low societal acceptance level on that for commercial and mercantile shipping.
We'll see if the audience have some questions as well.
Yes.
There are many questions. Wow, why did I ask all those questions? Should we start off with two ones here and then...
My name is Gerhard Muggen, BTG BTL. You have an ambition to replace the fuel on the two-stroke engines, which I think is a good technical choice. The disadvantage is it's the lowest cost fuel you have on Earth. So do you see any intermediate step? First go to the four-stroke engines, which having a higher price.
It's a good question, and depending on which fuels we end up on is going to be part of the technical due diligence to figure out which engine setup is going to be most optimal for that. For the operations we're currently doing, the two-stroke is better. If we can just get the speed down, we have really, really good propulsion from that. And it works with alcohols, it works with LNG and so on. But if we figure out a fuel stream that is not optimal for two-stroke, then obviously we're going to revisit that and try to figure out how to make the best possible ship design to reach our goal.
Yes, please.
My name is Ingo Machenbach from Statkraft. You had quite an impressive matrix on fuels that you are investigating, apparently. But when talking to vessel owners or shipping companies, you are probably the ones with the most international routes. You are going into many different harbors.
Yeah.
And I saw that you had quite a few of gaseous fuels in your matrix.
Yeah.
And how viable is that? Knowing that already the LNG business is limited to certain harbors. So I would imagine that if you build a new vessel, you want to have the flexibility to route it all over the place, and that would require you to have the infrastructure available at all the different harbors. So how is that working out when you go to, like, for instance, ammonia, which is a very new fuel, or even hydrogen for that matter?
That's a good question. So yes, you're absolutely right. We operate on a global level, and it's not possible for us to start moving towards fuels that we can't source where we're going. I mean, the alternative would be to have a tank ship follow us side by side, and that's not going to be sustainable, so that's not going to happen. And I think over time, much like we see with the LNG ports becoming more and more utilized all over the world, depending on the need of the shipping sector, and also on our own very active lobbying. So you notice that we have 70 terminals already all over the world. So that might be a place for us to start. Ideally, we don't want to drive this alone. We would like to see an industry push broadly for this. Otherwise, it's not going to have the effect that we're hoping for. And it's part of the journey for us to figure out how can we secure some kind of fuel flexibility, and how do we scale up the production, supply chains, delivery, etc., in a sustainable way. Some of the thoughts going into the three candidates mentioned before is that they're readily available as large-scale fossil products already. So should we end up in a situation where we enter a port and can't get the biofuel supply, it might be possible for us to make it to the next port on something that's then fossil, but still has less harmful emissions than the fuels that we're using right now. It's not ideal, but it does provide some flexibility. And I think no matter the fuel candidate that we're looking into, it's part of the calculations that we try to make. If it's really a vanity type of fuel, something odd that's not readily available anywhere, then a lot more thinking needs to go into the supply chain and how we're going to secure that we can actually move the goods that we want to move for our customers.
Thank you. A question back in the room. Yes, please.
Keith Simons, we had an interesting discussion yesterday.
Yep.
And of course, I never say never. I'm not sure about ammonia. I would argue LPG, and of course bioLPG should be on your list. But
I would expect that you would.
But thinking about a hybrid approach, is sail an option? Wind power?
I think for some vessels, definitely yes. And our former colleagues at Mærsk Tankers, who are now out of the group, they've even started installing Flettner rotors, for instance. We do get odd projects every once in a while with like these huge kite surfer kites that we could install, and depending on the direction of the wind and how much it blows, it might reduce consumption. We try to group that into efficiency gains, as with everything else that might have a positive effect, but probably is not a standalone solution. So it's on our radar. But for us, I mean, the entire deck is completely full of containers. So it would need to be a really, really good solution in order to get us to take the containers off.
There is an option for one more question, and I will, from a gender perspective, choose you.
Which one of the two?
Hi, I'm Sina Agren from Research Institutes of Sweden. I was really interested to hear about the ammonia as an option. Mm-hmm. So the ammonia is already produced today on a large scale based on fossil fuels. So how are your thoughts? And it's also used for fertilizer. So you said the electrofuels don't compete with food production, but in fact it does.
Well, the carbon-based ones was what I meant, but you're right.
Okay, yeah. So the thoughts on decarbonization of the ammonia industry, and do you work together with the fertilizer industry on this question?
So right now we're looking into the feasibility of using it. Ammonia is used today in fuel cells, for instance, so we can use it for auxiliary power if we so choose on board the vessels. To actually use it for internal combustion, which is what I was talking about, we would need an ammonia engine. None such exists. There's lots and lots of talk around the industry, and some of the OEMs saying that they intend to try to build an ammonia engine. And whenever that arrives, that will factor into our decisions. Of course, it's going to be paramount that the annual production of ammonia then be increased, because otherwise we would be competing. And also, as you mentioned, right now all the ammonia is fossil. So it's, I mean, a theoretical possibility that in the future you could use solar and wind to do green hydrogen through electrolysis, and then you add your nitrogen and you end up with some kind of green product. And how best to utilize that, how much goes to the agricultural industry, how much goes to other industries and for explosives and anything else, and how much would then go to transport. That's all something that we would need to have discussions about with the other industry players, if and when we get to that point.
All right, thank you so much. Thank you, Anne Sophie. You will have just a small gift also. Thank you. Thank you so much. I'm sorry that we cannot have all questions here. Now we introduce to you Henrik Dahlsson. You're a senior advisor at Sustainable Transports at Scania. So now we move to road transport and I guess heavy vehicles. It will be very interesting to see what you have to say about driving the shift to a sustainable transport system here and now.
Okay, now, was a high volume. Thank you for the invitation. Thank you for the interesting speeches before me from Anna and Anne Sophie. They put it very well about some of the key challenges that we're facing together. I would like to speak about the role of biofuels for Scania and how we can use biofuels to cut emissions here and now. Scania is a global manufacturer of trucks and buses and engines, but here I will talk about the truck segment. We have four main drivers when it comes to sustainable transport. Our cities are growing, we have congestion, we have pollution. Half of the world's population live in cities, and that will grow in coming years. We have the issue of energy security, to be self-reliant on energy, that is actually geopolitics today. And of course, climate change, the Greta effect. And looking at these four drivers, climate change, energy security is the answers. Biofuels is the answer to these drivers. And we have a key challenge in coming years. According to the carbon law, which is outlined by Johan Rockström, a climate scientist in Stockholm, also based in Germany at the moment, we need to halve our emission by cut it by 50% every decade to reach zero emissions by 2050. This is the biggest transition and the biggest challenge that our industry is facing. And to be able to reach that goal, biofuel has an essential role because it can reach the CO2 reductions here and now. If we look at the drivers in a broader perspective, we see that the whole transport industry is in a transition, just like the society as a whole. Sustainability, urbanization, and digitalization, that is the global trends. And the market, the transport market, answers these trends through electrification and biofuels, automatization, and connectivity. So besides our discussion on biofuel, we have some key new technologies through automatization and connectivity, which changes the whole setup of doing transport business. There are three main pillars when we talk about sustainable transport. And our view is that we always need to have these three pillars in mind when we talk about sustainable transport. Energy efficiency, of course, that is the DNA of Scania. To put it very simple, the engine and the vehicle needs to use as little energy as possible. And then it comes to electrification and biofuels. We need to choose the options that have a very high CO2 reduction rate. And smart and safe transport, we need to do the logistics in a much smarter way. And here connectivity and digitalizations are a part of that solution. And looking at these three parts, energy efficiency is something that we are working on at the moment. We have all these three alternatives available, alternative fuels and electrification. But looking at smart and safe transport, of course, safety is a key issue. But the main, I think, challenge for all is the smarter logistics in the long run, because we have an increased transport demand, especially with e-trade. So to reach the 2030 goal or the 2050 goal, I think limiting the use of energy in the whole transport system, that is the biggest challenge of all. But what do we do at Scania to provide solutions for the customers' needs? Yeah, we are proud to say that we have the broadest range of vehicles with alternative and renewable fuels on the market. We have biogas, pharma, RME, HVO, ethanol, and a hybrid solution with HVO. And all of these alternatives on the Swedish market, they have a very high CO2 reduction rate. And our idea with presenting this broad range is that the alternative or renewable fuel should be the standard, and the fossil diesel should be the alternative. That is the new setup that we have to discuss on the market. Looking more in detail on the motor engine range, you can see that we have all our Euro 6 engines. They are certified for HVO 100. We have 3 gas engines. We have 5 engines for pharma, RME. We actually have 2 ethanol engines because we have a 9-liter next year also. And looking at these ranges on horsepower, we can meet every need from the customer actually with a renewable fuel. And talking about biofuel production, we always come into the discussion on using land and forestry resources for this. And it's clear that we have a lot of idle land in Europe to be used for the production of biofuels. We can see here the availability. For example, the figures are from Eurostat. Abandoned cropland in the central and eastern part, and in total the 23 countries. So it's clear that we have the resources in a European perspective as well in a global perspective to produce more biofuels from cropland and from forestry. And the IPCC reports, all their scenarios are actually counting on an increased use of bioenergy. But looking at the EU regulations and the EU Commission's view on this, it's actually a policy that is now working against these goals and targets. We have the state aid guidelines, we have the ILUC regulations and limits in Renewable Energy Directive, and the cap on the use of food-based biofuels. We see this as a major problem, that we have the resources, we have the knowledge, but we lack the right incentives and regulations to make it possible. And to make it possible, we have to work with a broad range of actors. Here are only some of them, of course, to get the deal done. Together with transport buyers of both transport and our services, transport companies, of course, fuel suppliers, and we should add, of course, the research community, the policymakers, and the NGOs. It is together with all these actors that we are creating partnerships and driving this shift. And this is a picture to show. A colleague of mine said that when he got the question, what kind of truck shall we buy? What kind of fuel shall we focus on? And he said that, well, from my perspective, we have to do all of these things at the same time. We have to work with the alternatives that are commercially available today. And we have to work with a new technique that is not really commercially available at the moment. So from a custom point of view, we have the possibility of offering the biofuels in a broad range, the connected services, fuel saving, of course, and driver services, which also cut fuel costs. And looking at the bus segment, electrification is there already. But in a number of years, we will see more of electric roads. We will see the autonomous vehicles at construction sites, harbors. And we will also see platooning, where vehicles are connected to each other, and the vehicle in the front actually is driving the whole caravan, driving fleets, the total fleet. So to summarize this, biofuel is the answer to the key global drivers for sustainable transport. And we cannot meet the CO2 targets without biofuel. And we need to combine it, of course, with electrification. There is no competition between the two. And as I said, the greatest challenge of all is to minimize the energy use in the whole transport sector. We can produce more biofuels in Europe without competing with food production, and we need an EU which actually supports this development. And the only thing we can be certain about is the uncertainty of the regulations in this field. Of course, I wish that it should be a more long-term view on the regulations, but we have to be frank also. We live in a changing world, and also policies that are changing. So from a customer point of view, the person who buys the transport has to accept a level of uncertainty and take decisions according to that. Set strategies and goals to curb emissions, and choose between the alternatives that are available. Combine these fossil-free alternatives and minimize risk when it comes to uncertainties of regulations or tax deductions and so on. And the last point, where you are very important in our collaboration, we need to learn continuously through our collaborations and partnerships, together with the research community, policymakers, NGOs, and so on. Thank you.
Thank you. It seems to me that you that work with road transports, you are a bit ahead of the maritime sector and the aviation. That's right?
Yes, when it comes to the use of biofuels, we are. About 20% in Sweden of the total fuel consumption consists of biofuels.
So what kind of mistakes should they not do?
Oh, I mean, we are talking about different markets here. The fuel in the maritime sector is not taxed, for example, if I understand right. So there are different economic incentives to invest. And we talk about different volumes, of course, also, which makes it difficult to actually compare. But in Sweden, we have worked a long time with biofuels and this broad range. We have a policy which has supported end use as a rule rather than production. This might change, but this has really stimulated the use of biofuels in the transport sector. For example, the tax exemption for high blend and clean biofuels.
All right, then if I put it another way, I mean, when you're working on alternative fuels, what makes things a success to your industry? I mean, is it engagement with other industries, or is it like working more with policymakers and working with academia, or how do you work forward to come into your situation?
I think it's a combination. I mean, we wouldn't be where we are if we hadn't had some of my colleagues at Scania that has been working with biofuels for a long time, Eva and Magnus. So there is a commitment from the industry, several OEMs. There is a committed research community, centers like F3 here. and other initiatives in the research community. And I would say also national government bodies have supported several initiatives in the industry and in the research community. So, so it's a mix of all of these factors, actually.
All right. Some questions from the audience. Yes, please.
Rob Holland from University of Southampton and Supergen Bioenergy Hub. I'm actually recycling my question I was going to ask last time, but so it applies to everyone. I'm quite interested, what has been the driver for you as a business to kind of go down this route? So is it kind of a corporate decision? Is it individuals in the company who've seen this? Is it your customers who've been asking to do this? You know, what are the sort of factors that have led to this transition which you're obviously going through?
Yeah, I mean, it's clearly that the customers are driving this shift. It's even more so now, I would say, than before. My colleagues can complement that picture. I would say that for maybe 20 years ago, it was a policy-driven transition with problems with air quality in cities, for example. That was a way to promote natural gas and biogas. And from a municipal point of view, there's the residue problem that needs to be handled. So it was very much from a public policy point of view. I think today we see a much stronger market force among private actors, that the customers are demanding fossil-free alternatives. They are demanding substantial CO2 emissions that need to be cut. All the main transport buyers in Sweden, the big companies like IKEA and ICA and others in the food sector, detail sector, have very, very high climate goals. So it's a trickle-down effect also. And I would say that if you don't have this offer, then you're not relevant. It's clear today, and it will be even clearer tomorrow. It's the only way to actually survive as a business. If our customers become profitable with these renewable alternatives, then we become profitable.
Thank you. Any other question? It was nice because that was my question I had as well. All right. Thank you so much.
Thank you. Thank you.
Thank you. You have a small gift here for you as well. All right, friends, we are just on time. There will be a coffee break now, half an hour coffee break, then parallel sessions in this room. There will be a session on potential for biochemical and biomaterial byproducts alternatives. In the room F2, there will be a session on environmental and social impacts of European biofuel deployment. And please remember, you who are in the room F2, when that session closes, please come back to this room immediately. All right, nice coffee break.